Hello everyone. This is the second video in the AI video series, and the first one I hope you liked it, the AI 101. Now this one is obviously in the hottest topic in AI called generative AI or Gen AI in short. Okay, so let's dive in. So first, let's see the business impact of generative AI. As McKinsey report says is going to add 2.6 to 4.4 trillion US dollars annually. Okay, so every year is going to sort of add 3 to 4 trillion dollars in the economy. Okay, uh, and the high tech, retail, banking being the top sectors here. Okay, so they will be sort of impacted the most, which is kind of interesting. But apart from that, it's going to have a very wide applicability, right? I mean, the first time kind of in a history of this tech that it's not just limited to three or four sectors, but we'll see. I mean, it's like, probably like, all sectors, right? And we'll see that in a bit. Okay. The next thing which is interesting is that it's going to penetrate new areas like creativity, right? I mean, earlier, like, these were sort of hard, like creativity and knowledge work were kind of difficult areas to penetrate by AI or like some sort of automation, right, where it's going to kind of do human like things here, right, like like a very interesting poem or write a very interesting novel, right, or knowledge work, right, which is kind of requires a little bit of cognition, right, some ability to comprehend, ability to reason, right, which is kind of interesting that this Gen AI is capable of doing. Okay. Uh, the next thing which is also interesting is that it's going to raise the global GDP by 7% in the next 10 years, right? So, I mean, if you look at the history of economics, right, what happens is there is some sort of a revolution, like an industrial revolution that happened like a century ago, right? So that time, what had happened was like, maybe the main source of GDP was like agriculture, right? Or some sort of, uh, things that were powered by animals, right? Now, after the industrial revolution, that time, like, this GDP had stagnated, right? When the industrial revolution happened, right? And then there was a big boost after industrial revolution, right? And then it went up, right? So now if you see, right, before GenAI, like, if you see the GDP had stagnated with a little bit of, whatever incremental thing it had been doing for last decade, right? Now kind of GenAI is looked at as a next boost, right, which is kind of a phenomenal for the century, right, which is going to give a boost of 7% over the next 10 years, right, which is kind of an interesting phenomena here. uh, Now is going to impact 10% of tasks carried out by 80% of workers, right, so which is like a very wide impact, right. It's kind of a significant, right. Now, since we are talking about AI, right, even within AI, right, generative AI is considered to be the biggest sort of, a business impact phenomena, which is going to have 15 to 40% of AI impact would be by Gen AI, right? I mean, which is kind of, interesting part. Okay. So I thought it will be interesting to discuss and share this with all of you. Now, this is kind of, a matrix by McKinsey, right? So as you can see, uh, all the business functions, I mean, like, 7, 8 of business functions that they have listed across like, 15, 20, 30 sectors, business impact, if you see, right? I mean, it's like, everything is getting impacted, right? Some of them are like, dark, very high impact. Like, if you look at this high tech sort of, software engineering, right? It's the highest impacted thing, right? I mean, it's kind of, what you can see from this matrix, right? And then it's like, pretty much, I mean, this is the one, right? High tech software engineering, right? And then if you look at this marketing and sales, right? It's like, it's almost like, very dark if you see across these sectors, right? Which is kind of interesting, right? I mean, as you go towards right, it's kind of, talent and organization, it's like, light, but I mean, this is kind of an interesting thing to see, right? I mean, it's very wide impact, it's touching everything, right? I mean, maybe some of them may not be impacted at all, right, which will be kind of, interesting to see, right? I don't know, banking, like, product R&D, right, which is like, pretty light, right? I mean, which is kind of interesting, right? Product R&D in general is light for some of these sectors, right? So again, interesting sort of analysis, but as you can see, it's very widely applicable across 30 sort of sectors, 8 to 10 business functions of these sectors. Okay, so what is generative AI? Okay, so as the name suggests, it's about generation, right? So it's about creation, it's creating something new. Okay, so it can produce high quality content as if it is done by a human. Okay, I mean that is a key here, right? And that's where it's the intelligence, artificial intelligence, right? Done by a machine like a human, right? A generation creation of new high quality content. Okay. Now, the first sort of domain is a text, obviously, right? I mean, all of you might have tried Chat GPT, right? Which kind of made this Gen AI very sort of interesting, or kind of very popular, widely understood. It generated wide interest, I would say, right? But it's not only limited to text now, right? It's like images, right? You can have very high quality human like images created by these like paintings, right? Or you might have heard about some paintings done by this Gen AI selling in auctions in millions, right? Then it's audio, right? It can mimic somebody's audio, right? Or it can sort of project somebody's audio as something else, right? And it's starting in the videos, right? I mean, you might have heard about like even in the film industry, like Gen AI is making impact. Okay, so that is kind of the generative AI kind of scope. Uh, Then obviously you must have heard about ChatGPT, right? So that's how it started, right? Google Bard, right, which is now also known as Gemini, right? Bing Chat, which is sort of Microsoft's uh, Gen AI chat application. You would have also heard about co-pilots, right? So I mean, if you are a software engineer, you would have heard about Microsoft GitHub Copilot, right, which helps you write code. Not only write code, but do some sort of unit testing, right? Integration testing. Okay. Now these co-pilots now no longer limited to only software engineering. There are co-pilots in various domains, right? Even in the space of legal, right, finance, right? And you'll keep hearing of these more coming up, right? I mean, just like after ChatGPT, you might have started hearing about GPTs, right? Like a Bloomberg GPT, so on and so forth. So just like after GitHub Copilot, now people have started talking about co-pilots, right? So co-pilots for various domain sectors, right? Even now, when you look at web search, fraud detection recommenders, right? You'll start seeing Gen AI there. Okay. Now, one thing to know is it is supervised learning, right? As we have seen in our first video, right? It's not like unsupervised, right? It's mostly supervised learning. But what is the difference from the traditional supervised learning? That it is on a very large scale, right? So all these models in Gen AI, you'll see have billions of parameters, unlike like hundreds of thousands of millions before, right? Now, since there are so many parameters, they need to be trained with large amount of data, right? So basically it is supervised learning, but it is like supervised learning on a very large scale, trained with very large amount of data, right? So that is the sort of fundamental basis here. Okay. uh, Now what it actually does, right? So it's about sequence model, right? So basically you are given a sequence of words, right? And it predicts what would be the next word, right? I mean, that is kind of a basic principle in generative AI, right? I mean, you are given a sequence of words and it predicts what would be the next word, right? Then it takes that next predicted word as an input and then predicts the next word, so on and so forth, right? I mean, that's how you sort of do the conversation, right? It's kind of word after the word, right? Based on the previous context of conversation or question, you give an answer, right? And that's how it flows. uh, Another fundamental aspect of generative AI is what are known as foundational models. Okay. So you might have heard this term, right? So these are pre-trained models on large corpus of data. Again, one kind of, a foundational model being GPT-3, okay? But they get fine-tuned for a specific task, okay? So GPT-3, when it got fine-tuned for question answer or text conversation, became a chat GPT. Okay. Now that brings us into the next topic of LLM, which are also known as, or which are the large language models. Okay. So it started off with foundational models, right, which are kind of, were more generic, right? They're pre-trained on large corpus of variety of data, right? It need not only be text, it could be images, videos, multimodals, right? Acoustics, right? Uh, but for they to be useful in an application, they need to be fine-tuned for a specific task, right? And that's what is done by, or when you kind of fine-tune them, they become LLMs. Okay, and popular LLMs being Llamas, Llama series, Llama 2, Llama 3, right? Now, these days, these foundational model and LLMs kind of have become sort of interchangeable, right? Because foundational model as such is very hard to use directly in an application, so it has to become a LLM, right? So I mean, practically, like LLMs are sort of, a usable version of foundational model, as you can say, okay? But this is what is to it in generative AI. Okay, so with that background, let's get into specifics of various aspects in generative AI, right? I mean, the first and foremost, you must have heard about prompt engineers, right? Prompt engineering becoming a popular discipline, right? Or a popular sort of, a job function, you might have heard, right? So what it is, right? I mean, it is basically asking the right question, right? So even in colloquial language, I mean, we say that, oh, you should know how to ask the right question to get the uh, good information or accurate answer, right? I mean, basically that's what prompt engineering is. So you need to know how to ask the right question to the LLM, and then you'll get the answer, right? You'll get a good answer, right? And that's the trick here. Okay. So now what goes into the good prompt engineering, right? So you have to first give a sufficient context, right? So now you have to tell the LLM that, hey, like, uh, my following question is in, like, a retail industry, right? Or in a financial domain or in the healthcare domain, right? Now, uh, even within a financial domain, right, you need to tell whether it is about investments or banking or insurance, right? Now, if it is insurance, you need to tell whether it is auto insurance, life insurance, so on and so forth, right? I mean, basically, that's what goes into the sufficient context part of prompt engineering, right? Now, the next thing is you have to describe the desired task, right? So you have to tell LLM that, hey, what is the task that you want the LLM to perform? So, like, for example, building on our previous thing about, say, insurance, right? So now, if it is in the insurance within the financial domain, right, you need to tell whether you want LLM to sort of, uh, uh, handle a claim, process a claim, or, create a policy, or sort of, find a premium for a particular customer, right? I mean, that's what has to go in prompt engineering for LLM to give you the correct answer or the interesting answer, right? Or an answer that you can use to sort of, go forward. Okay. The next thing is you have to guide the LLM to think through, right? So you need to tell that, hey, think step by step, right? Or so on and forth, so on and so forth, right? I mean, maybe you have to tell that, hey, what are the guiding principles for LLM to sort of, arrive at the answer from the question that you have asked. Okay. Now, uh, this is a little bit of iterative process, right? So you don't have to, like, do all the thinking upfront, right? But you kind of, think reasonably through your problem, right? Giving sufficient context, describe the desired task, guide to think through, right? And then you prompt it, right? Now, when you prompt, the LLM gives you an answer, right? Based on the answer, you could iterate, right? So you say, for example, you asked LLM to write code, right? Now LLM gave you the code, and then you think maybe there is some bug in it, right? So you ask, hey, uh, Mrs. LLM, you gave me this code. Can you see, can you spot any bug in it? Okay. And we'll see some of these design patterns in subsequent videos here. Okay. Now, what are some of the techniques in prompt engineering, right? So the first one is called shorts, right? So shorts is what? Like a zero shot is you basically give the prompt, right? But you don't give any example, right? Now, what is a one shot? So in one shot, you kind of, give the prompt, ask all your questions, giving context, describing task, guiding through, right? But you also say that, for example, if I would have asked you foo, your answer would have been bar, right? I mean, that is one shot, right? In a few shot, you give more examples. Okay. I mean, that's what the short technique is all about, right? The next one is chain of thought, right? So you say that, okay, like, you ask the question, you do all this, right? But then you also guide it through the chain of thought, right? So if X, then Y, right? I mean, you kind of uh, tell LLM this will be your chain of thought, right? Now, this chain of thought can even become more complex where it can be a tree of thought, right? Because now it need not necessarily be just a linear chain, right? It could be a complete tree because at each node or at each sort of a decision making point, you may have multiple choices, right? And it kind of grows, right? So now kind of you can think of this sort of complexity that is involved in this technique of prompt engineering, right? And the next one is hybrid, right? So you can combine like all these like a shorts, chain of thought, tree of thought, right? And that's how you kind of build your prompt using all these techniques, right? Now, a few interesting uh, concepts here that go into prompt engineering, right? So first is a system message. So basically, a system message is kind of telling LLM that, hey, LLM, you are my financial advisor, right? So all throughout the conversation, LLM knows that, hey, I'm playing a role of a financial advisor, for example, right? The next one is configuration, right? So when you kind of configure LLM, right? Say, for example, one parameter is called temperature, right? So basically, you tell LLM that whether the answer has to be consistent, right? That way, it will kind of keep giving the same answer if you ask the same question. But if it is more like a conversation to keep the conversation interesting, you may want to say the same thing in different words at different times, right? So with temperature, you can control that based on your application, right? And these days, it's not like, just a single LLM, right? I mean, you talk to multiple LLMs. So there is an additional layer that goes in between, which is called as AI orchestration, right? So where you kind of talk to this AI orchestrator, and then sometimes AI orchestrator figures out what LLM to go to, how to sort of, combine answers from multiple LLMs, right? Depending on your question, it may go to one LLM to another, right? So on and so forth. So uh, that is all goes into the prompt engineering, okay, as we know it. uh, Now, kind of just to give an idea of like how it helps in real life, right? So I mean, uh, a traditional supervised learning, right? You basically would get some labeled data, right, which will take like a month, right? To train model on data, it might take like a multiple months, right? Then you deploy and run the model, right? It will be a few months, right? Now, with prompt-based AI, right, you already have this sort of pre-trained foundational model or LLM, as we saw, right? Now you just have to specify a prompt, right? It could be minutes or hours depending on the iterations that you may have to do, right? If you get it in the first iteration, like it could be minutes, right? If you want to iterate uh, multiple times depending on number of iterations, it could be hours, right? And then you just deploy, right? It will be hours to days, right? So I mean, basically this like a few months like or a year long cycle has been squeezed into like a days, right? Or maybe at most a week long cycle, right? I mean, that is kind of the benefit of prompt engineering in terms of execution of the problem, right? It kind of, shrunk the whole cycle of a year into days. Okay. What are some advanced techniques beyond prompt engineering? So they are fine tuning, instruction tuning, RLHF, which is reinforcement learning human feedback, and a custom LLMs. Okay, so we'll uh, see all those in detail in a bit. Okay, so before we get into fine tuning, okay, so now how are LLMs pre-trained, right? So let's say uh, you have a sentence, my favorite food is a bagel with cream cheese, right? So then what it does is, I mean, as we know, it's like a sequencing, right? So you need to tell LLM that when you see my favorite food is, then it should give an answer of bagel, right? Now you take that output into your input, you say my favorite food is a bagel, right? And the next word would be with, right? I mean, basically this is your training data, right? On such like hundreds of billions of words, or like tens of billions of sentences from which these words come. These LLMs are pre-trained. Okay, now what happens in fine tuning, right? Now let's say you got this LLM, right? And now you want to sort of fine tune this LLM to sort of be kind of an optimistic LLM, right? Or sort of LLM that wants to give or should be giving happy answers, right? Then what to do, you basically fine tune it with like now this is a much smaller corpus, like thousands or tens of thousands of words, right? Like maybe hundreds of thousands of sentences, right? These will be all happy sentences in this case. What a wonderful chocolate cake, the novel was thrilling, right? And then you kind of do the same sort of fine tuning or further training of the LLM on these words, right? Now the advantage here is that this fine tuning is like this pre-training could have taken a very long, like a chat GPT took like months on like uh, thousands of GPUs, right? But this fine tuning, as you can see, it's a very small training data, right? So it can happen in like days and a very smaller resources, but the result that you'll get will be drastically different from the original LLM. So that's what the fine tuning is all about, right? I mean, we are fine tuning the LLM uh, with a small effort, but having a bigger impact on the outcome that it gives, right? It will be now highly optimistic LLM or highly positive LLM, as you can see. Okay. So when to use fine tuning? I mean, as we know, it's the next step of prompt engineering. So if it is not easy to define a task in a prompt, right? So obviously that's when you go to fine tuning, right? I mean, some of these prompts could be like, even a page long, a couple of pages long, right? But as you can see, fine tuning is a little beyond that, right? It could be like, tens of thousands of, I mean, not necessarily tens of thousands, but yeah, I mean, like, a few thousands words, right? So, little longer than a prompt, basically, right? What it can achieve, it can sort of be used for styling or branding. So let's say you got a LLM and you want to brand it for your organization, right? So then you sort of give your branding, typical branding statements, right? And typically marketing would do that, right? Or you want to style it for a particular way of writing, right? Or you can even do it for images. Okay. uh, you also do fine tuning for a domain specific fine tuning, right? So if it's a generic LLM and you want to fine tune for your domain, like a retail, right, or whatever, sports or technology, right, then you give sort of little bit of knowledge from your domain and fine tune it for your domain, right? You can do it for specialization, right? So if it's like a healthcare LLM, right, a palm, like a med palm, for example, from Google, and now you want to specialize it for like maybe oncology, or like whatever specialization you want to do, right? Then you kind of fine tune it with sort of knowledge from that specialization, and it would do that. Now how do you do fine tuning? It's like very simple. From the transformers library there is a class called trainer, right? Or actually you can even use reinforcement learning library. So there is a TRL, transformer reinforcement learning library. So you can use that for this sort of a fine tuning. And I have a sample code for this fine tuning in my GitHub repo that is given here in the GenAI uh, Git GenAI repository of my GitHub. Okay, so this is the first advanced topic beyond prompt engineering, which is fine tuning. Okay, next one is instruction tuning. So what is it? Basically, it is telling LLM to follow instructions. Okay, so let's say if it is a LLM, which is a question answer kind of LLM, right? So you need to tell LLM that you are a question answer kind of a LLM, right? Now, how do you fine tune, right? So you basically fine tune with question and answer data set, right? So help me brainstorm some fun museums to visit in Bogota, right? And then say your answer is sure, here are some suggestions, right? So this is how you'll construct your sort of, fine tuning data set to fine tune your LLM with this sort of instruction tuning, right? So you kind of, collect your instructions or question answer data, right? Construct a fine tuning data set, fine tune your LLM for such instruction tuning, right? This was the second advanced topic. The next one is reinforcement learning from human feedback, right? So, I mean, as we already know, reinforcement learning is kind of based on rewards, right? So what happens here? So you tell LLM to generate as many answers it can generate, right? Now you can do that by asking the same question again and again, or changing a configuration of LLM a little bit, as we know, right? So that now you have multiple or a lot of answers from the LLM for the same question, right? Now, where is the human feedback here, right? You give it to humans, right? So humans look at these answers from the LLM, right? And then they score them, right? So like, for example, um, our question here is advise me on how to apply for a job, right? Now, let's say the LLM answered, I'm happy to help. Here are some steps to follow, right? I mean, it's a very good answer. So the human would reward it or score it as 5, right? Now, if the LLM would have answered, just try your best, right? I mean, okay, I mean, it's not a very helpful answer, but not sort of, harmful. Okay, and then if it says it's hopeless, why bother, right? I mean, it's a harmful answer, right? I mean, it's a kind of little bit of derogatory, so the human would reward or score it the least. Okay, so now what you do, you further train the LLM or fine tune the LLM on these generated answers so that uh, LLM it's very likely that LLM generates answer with high scores, right? You increase the probability of LLM giving the answers that were favored by humans, right? I mean, that is what is done with this RLHF technique, right? And it helps LLM to give more helpful, honest, and harmless answers, right? So that's what the RLHF is all about, right? So it's a human input here involved here, right? And you might have heard about the kind of DeepSeek R1, right? I mean, it's trained on this sort of this reinforcement learning based technique. Okay. Uh, so now you must have heard about like oh, now there are like so many providers, right, or so many models out there, right? There is a OpenAI, there is a Microsoft, right, Anthropic, right? Now even within them, right, even OpenAI would have ChatGPT 3, 4, 4.0, right, so on and so forth, right? So that is actually just the cloud, right? I mean, all these models are there on cloud, right? Now, uh, you could use that, right? So for that, you have to kind of, just investigate what different models are for, right? So now maybe Palm, if you want to use from Google, right? Maybe if you are in healthcare, you want to use a MedPalm, right? Now, they would also have versions coming up, like we saw Llama 2, Llama 3, Llama 3.5, right? Now, even beyond these closed cloud models, right, which come from various providers, and of course, you can even access them from something called as Amazon Bedrock, right? Bedrock is kind of a repository of these closed cloud models, and you can use all of them, mix and match, right? You can sort of write a multi-agent flow, right? Uh, Even beyond that, there are some open source models, right? Like a Llama 2, Llama 3, right? Now, a lot of these models, you'll see them on Hugging Face, right? Hugging Face is a popular portal or repository of all these open source models. Now, uh, when you are choosing open source model, right? I mean, basically, one important thing to consider would be a model size, right? I mean, if you just want to use it on a laptop, obviously you cannot use like a very heavy model. Right? Typically, you can go up to like a 7 billion parameters model on a laptop, right? But now, if you just are looking for a basic knowledge, right, or a pattern matching, right, it might be good enough, right? If you have a higher resources like a server, right, and you want to have a more sophisticated application that can follow instructions like a conversational chatbot, right, then you go with a little higher model, right, order of magnitude higher, like tens of billions of parameters. Okay. Now, if you want to sort of, go for an even higher intelligence, right, a complex reasoning kind of application, then you go with this high, heavy models, right, which have thousands of billions of parameters, right? But then probably you'll have to go to a GPU, right, or you'll have to go to like a more powerful machine on which you can host them. Okay. So now let's dive a little bit into this uh, open source models, which are sometimes also called as custom LLMs. Okay, so now you might say that, hey, I mean, this is a lot of work, right? I mean, like, figuring out where the model is, right? I don't even know what I do with it, right? But sometimes, like, privacy might come into play, right? Like, it's a financial institute, right? Where maybe you don't even want what queries your employees make go out to the cloud, right? Uh, there could be some sensitivity involved here, right? Or maybe you just want to have a like a control over what people do with these, right? Because of some legal concerns or like some compliance reasons, right? Also cost, right? I mean these basically open source, I mean, cloud models, right? Typically, you might have heard about a word called tokens, right? So they deal in tokens, right? How many words you send to them in question and how many words you got back in answers, right? And sometimes it's difficult to control because what if like LLM gives a very long answer, right? You won't know, right? And you cannot contain the cost, right? Because based on the tokens, you will get charged, right? So that could be another reason, right? And last but not least, like a competitive edge, right? Like, for example, Bloomberg GPT was developed as a custom LLM by Bloomberg to keep a competitive edge in the financial domain by Bloomberg, right? So this could be a variety of reasons for which you may want to work with custom LLMs, right? Now, how? I mean, obviously, the first part is building them, right? Uh, the first basic thing is training, right? I mean, uh, uh, and the next thing is like even from scratch, right? I mean, as we saw, the transformers are the building blocks of GenAI, right? But then how many layers you want to have, how many attention layers, right? We saw even in the attention layer, right? There are different types, right? Cross or self, right? Uh, but how do you kind of how many fully connected layers, how do you stack them on top of each other, right? I mean that goes in the from scratch custom LLM, right? Again, I mean we're not going to go into the detail of that in this particular video, uh, but we'll spend some time how to use these custom LLMs, right? So I mean obviously you go to a place like Hugging Face, right? You figure out the model that you want to have, like based on these like model sizes, for example, as one parameter, or the model will give you a little bit of description for what domain it is, for what task it is, for what type of activity it is, right? Then you figure out the right model, you download it. Okay. Now, after you download, you want to host it. Okay. So again, I have a blog on Medium which talks about variety of ways of hosting it. Right. I'll share that in the comment section of this video. but a popular way which is also uh, convenient for end user is Olama. Okay, and that's how you host it. So again, I have another YouTube video for which I have given a link below on this slide, which talks about how to do that in Olama. Right now, once you host it in Olama, you access it using APIs. Okay, so that's all about generative AI. Okay, so we started off with the basic concept, and we started off with prompt engineering within how to use generative AI, and all the way to custom LLMs. So again, if you like the video, click the like button, subscribe to my channel, give me feedback, and any other things you would like me to cover in this series of AI videos, right? The first one was the AI 101. The second one is generative AI, and we'll keep moving along on, like, sort of agenting flows, multi AI agents, and variety of frameworks in the multi AI agent domain. Okay, good luck exploring AI and generative AI.